Yes, friends, in this video I am telling you about Wallenstein graph. Here is the table for a moving body, time in second, velocity in meter per second. At 0 it is 0, 1, at time t equal to 102 meter per second, at 2 it is 4 meter per second, at 3 6 and so on. Now to plot Wallenstein graph, what we do? We take velocity along y-axis and time along x-axis. And we mark the point here 2 and 4 and then 6, okay, and then 8 and then 10 and 12, and we join all these points. So we get a straight line making certain angle theta with time axis. Okay. So what information we can get from this graph? What information you can get from this graph? Number one, velocity at any time. Velocity at any time means, suppose you want to find velocity from this graph at 4 seconds. So go 4 and 8. So at 4 seconds, velocity is 8 meter per second. At 6 seconds, it is 12 meter per second. At 2, it is 4, and so on. The first thing is there that we can obtain velocity at an instant. Number 2, as we know, we can find out acceleration. First of all, acceleration from this graph. How? We know, I should write here, it is, actually I have used notation different. Let it be Vt2 minus Vt1. I have taken this time T2, the velocity at this time is taken V22. T1, velocity at time 2, T21 is Vt1. Actually, this whole is Vt1, Vt2, and this is Vt1 here. So this difference here come out to be Vt2 minus Vt1, and this come out into T2 minus T1. We know from definition of acceleration, A equal to Vt2 minus Vt1 upon T2 minus T1. And from this graph here, from Vt graph, Vt2 minus Vt1 upon T2 minus T1 is equal to tan theta. Theta is the angle made by this line. So corresponding are equal to slope. So from Wallenstein graph we can say slope of Vt graph is equal to acceleration. Greater the slope, more the acceleration. You can write here, greater the slope, more is the acceleration. And you know what is acceleration? Change in velocity per unit time. By definition, change in velocity per unit time. Vt2 minus Vt1. Here I have taken only magnitude. No? And now if Vt graph is a straight line, making certain angle theta, with time axis. Then average acceleration. Actually, Vt2 minus Vt1 upon T2 minus T1 gives us average acceleration, because for large interval of time, the change in velocity may not be same, but here in this graph, velocity is changing at constant rate. So what I am telling, at certain theta, then time axis, then average acceleration and instantaneous acceleration. Are equal. But if Vt graph is not a straight line, if it is a straight line making certain theta, then average velocity, average acceleration and instantaneous acceleration will be the same. Now, if Vt graph is straight line, it may be like this, T or B, may be like this, or it may be like this, depend on situation. Then if the curve Vt graph is curved, if Vt graph is a curve, then average acceleration, A average, so again Vt2 minus Vt1 upon T2 minus T1. आपने यहाँ से T1 लिया, ये Vt1 है, यहाँ T2 लिया, ये Vt2 है, this value is Vt2. So it is again Vt2 minus T1 upon T2 minus T1. But to find instantaneous acceleration, if you want to find out distance, suppose at this time t here, so you have to draw tangent here, and slope of tangent to Vt graph. This is very important to know. To find, yes, you can write directly the slope of tangent to Vt curve at any instant, at given instant will be instantaneous acceleration. Instantaneous acceleration. These are very simple facts, but when we start learning, we feel that we are going to do something very difficult. No, physics itself is very simple, provided you start from the fundamentals. First start fundamental, like to learn arithmetic, and you need multiplication, division, addition, subtraction. So first you need counting, then you need tables, and then you need practice of addition, subtraction, and then multiplication. The same way here you have to come to fundamental first. So I am taking very fundamental things. Now slope of tangent is equal to, so here in this graph slope is increasing, so acceleration is also increasing. Here acceleration is not constant, here acceleration constant. In this graph acceleration constant, here acceleration is not constant. Here this graph slope of tangent, यहाँ पर टेंजेंट डालेंगे तो ये टेंजेंट भी आएगी, यहाँ पर डालोगे तो ये ऐसे होगा, तो this angle become less, and when actually it become parallel time axis like this, So angle between time axis and tangent is 0. Angle between parallel lines 0. So acceleration becomes 0. And therefore, if VT graph is a straight line like this, VT graph is straight line. Say it is 5 meter per second here. It remains always 5 meter per second. So acceleration is 0 because velocity is not changing. Acceleration is not velocity, it is change in velocity per unit time. Okay. So this is our talk about acceleration. If VT graph is straight line parallel to time axis, then acceleration is 0. You can make note. Now, just now I plot this graph. Here T, here V. Suppose it is 5 meter per second here. 1 second, 2, 3, 4, 5 and so on. And so the graph comes like this. So now if I say, okay, find the distance traveled by a body if its speed is 5 meter per second in 4 seconds, then simply we say 5 into 4, 20 meter. So 20 meter here, 5, this 4 is this. You see, it becomes rectangle. So this rectangle area here is telling displacement. So displacement. How to find displacement? Area under VT graph. VT graph gives us displacement. Actually displacement I told you change of position है, but if body moving in straight line, then displacement and distance are equal. And here, you know, velocity may be negative as well as positive. Suppose we get velocity graph like this. It is like this here, T. Suppose it is 2, 4, minus 2 and minus 4. And then it is, suppose it is minus 4 here. And then become constant. And here the time 1, 2, 3, 4 seconds. So what is the displacement in 4 seconds? So we have to find this area, this area, this area, this area. This area positive and negative. So displacement here may be negative. Here velocity was degree becomes 0 and then start moving in opposite direction. With this, here there is acceleration. Here retardation, here is acceleration in negative direction. So, but if body moving in straight line, so here distance traveled to total area दोनों ले लेंगे positive. But displacement may be 0, may be negative something. Area under VT graph is equal to displacement. Okay. Now suppose in this graph you want to find out displacement in time interval T1 and T2, T2 minus T1. So here this area under the graph, this is the area under the graph. So how to find this area? There are two methods. It is trapezium. Area of trapezium is sum of parallel sides into distance between them by 2. तो यहाँ पर ये जो एरिया हो जाएगा ये होगा VT1 area equal to VT1 plus VT2 into T2 minus T1 upon 2. This is one method. Second, this area sum of area of rectangle plus area of triangle. Area of triangle, you know, half base into height. I understand people, children forget formally, but if you be remain alert and attentive, then you can tell. So this way here I have told you about क्या भाई velocity time graph. So we can find out velocity, then acceleration, then displacement from VT graph. The displacement is equal to under radial graph. Thank you.